So, till here we got to know that there are some inequalities. Inequalities in the concentration of iron and inequalities of the total charge at the outer part and the inner part of the cell. Here we can see net total charge, resultant total charge at the outside of cell surface is positive as well as the inner side is negative. This inequality, you have two inequalities here. Inequalities of concentration of iron, inequality of total charge at surfaces of cell, neuronal cell. And which surface? One is outer surface, one is inner surface. These inequalities causes the gradient. This will cause the concentration gradient, this will cause the electrical gradient, and this gradient is finally responsible for ionic movement. Because of this gradient only, ion will move. So, here we can say this will result in gradient, and due to this gradient, ion movement happens. Now, question is, can ion directly move through the cell membrane like this or like this? Suppose this is a sodium ion, suppose this is a potassium ion. So, sodium ion can go across the cell membrane from out to in directly, or the potassium ion can go across the cell into out directly. So, the question is, if this is a cell membrane, the outer membrane of cell is called cell membrane. If this is a cell membrane or plasma membrane, does it allow ion to move directly across it? No. The answer is no. The reason is cell membrane is selectively permeable. And it is hydrophobic in nature. And if you remember why it is hydrophobic in nature, just because of it contains lots of lipid in between, and selectively permeable, and you can say hydrophobic. Selectively permeable है, hydrophobic है, so you can understand the ion cannot go across directly. This is the basic problem. Ion cannot go across directly, and maybe this will be the beneficial for the cell conduction. Why? Because ion cannot move by themselves, so we have a regulatory system, or we need a channel by which ion can move across. So, you know, there are some integrated proteins. These are some integrated proteins. Suppose this is a cell membrane, this is a layer. If I zoom this layer, this is a layer. These are some integral proteins. This yellow color protein are shown here also. This is the integral protein, and these integral protein make some channel, and by these channel ion can come inside or go outside from the inside, and these are called ion channels. Ion channels. And which substance make these ion channel? Integrated protein. Integrated proteins make these ion channels. So, now question is, we understand what is ion channel. What type of ion channels are there? So, we can classify ion channels according to their status. Some ion channels are always open. Some ion channels are facultative or they are occasional. They open when specific condition comes. They open when the proper criterias are fulfilled. Then only these ion channels are opened, and these are called gated ion channel. You can understand by practical life example. This is a simple pathway. There is no gate. You don't need to open any gate, but there are some gates. There are some gates. At least to enter in this, you have to open this gate. So this type of ion channels are called gated ion channel, and this type of ion channels are called always open या just ion channel. Ion can diffuse. Directly, and opens and according to the specific condition, these gated ion channel are further divided. So now there are two major categories of ion channel, but we should know that ion channel allows at a time only either one ion or just a small set of ion. That means just you can say it allow only A ion, like A plus ion for example, or it can allow a set of ion like A and B, A plus B plus. This set is only allowed by to permit by this ion channel. But there is nothing like the lots of ion channels simultaneously can go across the one ion channel. For every ion there must be a different ion channel. There are different ion channel. Through the one ion channel, yeah, one type of ion channel only, either one ion can go across, or either the small set of ion can come across. So we can say here it allows either one ion or small set. Please note small set, not the larger group, not the multiple ion at a time, larger set of ions only. Now, if these are gated ion channel, there must be some specific condition. On the basis of this specific condition, we have some more classes of this gated ion channel. कुछ गेटेड आयन चैनल ऐसे होते हैं जो किसी मैकेनिकल कंडीशन में चेंज की वजह से ओपन होते हैं. देन वी कैन कॉल इट द मैकेनिकल गेटेड आयन चैनल. what can be the mechanical conditions here, like temperature, like pressure, length, stretching. This type of mechanical stimulus can open or close these gated ion channel. So one can be the mechanical gated ion channel, the category number 1. Category number 2 is voltage gated ion channel. The most common category found in the nervous conduction part, the voltage gated ion channel. These ion channel opens only after a certain potential difference gradient is created. So we can call it voltage gated ion channel. And last one is ligand gated ion channel. Only if a specific ligand bind with these ion channel, these ion channel will be open, otherwise they remain closed. So we can call them ligand gated ion channel. And if we want to understand it more, we can write here the specific condition: open only change in mechanical factors. For example, temperature, pressure. Voltage gated ion channel, open, specific voltage difference, and ligand gated ion channel, specific ligand. So, now we can classify directly ion channels into the 4 category. Which 4 categories? One is open ion channel, they remain always open. Second is the gated ion channel, which further has two type, mechanical gated ion channel, voltage gated ion channel, and the ligand gated ion channel. Now we can say the state of ion channel. If ion channel is closed, if ion channel is open, and if ion channel is deactivated. What does it mean? Status of ion channel. Maybe it is mechanical gated, maybe it is ligand gated, maybe it is voltage gated or something else. We have 3 status, 3 stages of ion channel. One is open. First we must look for the closed one. Closed. This is open, and last is inactivated, deactivated. Let's say this is an ion channel. This is a membrane. This is the ion channel. This is closed. You can see here, this is closed. This is not open. This is open. Any ion can go across it like this. And if suppose this is a inhibitor, or this is something which can permanently close ion channel for the longer time, that ion cannot pass through it for a certain period of time. Now it can be considered as closed or permanently closed, or the inactivated ion channel. This is like a cap, or this is like a stopper which is shown here to represent the inactivation. The status number 1 is the closed ion channel. This ion channel is closed for now, but it is ready to open. Suppose this is a voltage gated ion channel and it is closed for now. If the cell have a specific voltage gradient on, after which this ion channel will be opened, this ion channel will open immediately and allow ion to move across. So this ion channel, it is ready to open immediately. And when it will open? When the specific condition comes. If it is a mechanical gated ion channel, the mechanical condition will occur, this ion channel will be open. If it is a ligand gated ion channel, ligand will bind with it and this channel will be opened. And this is the open channel. This is self-explanatory. We can say ion movement is running through it. And what is this? This status is important because during nervous condition, this condition causes a specific part of nervous conduction, yeah, we can say the specific stage of nervous conduction, which is hyperpolarization part. We will see in a later while. So, this inactivated ion channel, these ion channels are temporarily closed, yeah, inhibited due to fatigue and will not allow for a few seconds. So, after the making understanding of the ion channels, we come to the membrane part, the neuronal cell membrane part. This is a potential, yeah, potential difference of cell membrane. This is the time. Just we can say it is the time axis. This is a potential axis. This is a time axis. So, now if cell membrane is at rest, neuron is at rest and neuron is not conducting any impulse, that means it is at rest, and the potential of the resting condition is called as RMP, resting membrane potential, and the approximate value of this is minus 70 millivolt. For most of the neurons, the value will be same for minus 70 millivolt, and the some other like some smooth muscle cell or some other tissues, it can vary. It can vary from the, it can be minus 45 also, it can be minus 90 also at the same time, but for most of the neurons, the resting membrane potential is minus 70 millivolt. Now, what happens if any stimulus comes? If any stimulus is received by a dendrite, maybe it is mechanical stimulus, maybe it is some electrical stimulus, anything, this membrane potential which stays here, this membrane potential goes higher. Why it is going high? Because this potential is the inner side of membrane potential. As soon as the stimulus comes, this is plus, this is minus, and it is a resting condition. As soon as the stimulus comes, some mechanical ion channels or some always open ion channel, through these ion channel, some positive ion, maybe sodium ion most of the time comes inside, and if sodium ions come inside, this potential is become less negative. Now, this resting membrane potential, which is at the minus 70 millivolt, now it will be at some higher level or some less negative values. Let's say it will be minus 60. From the minus 70, it goes to minus 60, which is less negative or which is higher value, but it is not enough to open some voltage gated ion channel. We already discussed that there are lots of type of ion channel. On every stimulus or every impulse which is received by dendrite, some ion channels are opened, and the first ion channel that will be opened is the mechanical gated ion channel. Mechanical gated ion channel can open on the small stimulus even. So, for the in response of every stimulus, some mechanical ion channel, mechanical gated ion channels are opened, and some ion comes inside, some positive ion comes inside, and this potential goes higher, but it is not enough to open the voltage gated ion channel. So, the polarity is disturbed, like outside is positive, inside is negative. This is called the polarity, and this polarity is disturbed, but it is not enough to open the voltage gated ion channel. So, the impulse will not be conducted because the voltage gated ion channel are not opened. So, Again, this is called the graded potential. Any potential which is higher than the resting membrane potential due to any stimulus, but it is not able to maintain the conduction, it is not able to maintain the voltage gated channel. This is a minimum value. This is the minimum value after which only the voltage gated ion channel will be opened, and this is called threshold value. So we can say it is V threshold or threshold membrane potential. When the resting membrane potential goes up to threshold or higher, the conduction will happen. Below this level, every change in the resting membrane potential, every change in the neuronal membrane potential will be called as graded potential. What is this? Graded potential. And now this graded potential is not able to make the conduction. So this polarity, this changed polarity is again have to be restored. So we can say here this changed polarity is maintained by some ion channels. The sodium ion channel came inside, तो वी हैव टू पुश देम बैक आउटसाइड ऑफ द सेल. तो इसमें आपके कौन से आयन चैनल्स होंगे जो अब ये आपका फंक्शन तो प्रॉपर हुआ नहीं है, तो जो फंक्शन प्रॉपर नहीं हुआ, ये जो डिस्टर्बेंस आपका हुआ, इस डिस्टर्बेंस को मेंटेन करने का काम कौन से आयन चैनल करेंगे. नाउ वी हैव टू स्पेसिफाई द आयन चैनल्स. देयर आर सम आयन चैनल्स, दे आर नोन एज सोडियम पोटेशियम एटीपेज आयन चैनल. What are this sodium potassium ion channel? This is a cell membrane, and let's say this is a ion channel. Site number 1, site number 2, site number 3. क्यों बना रहे हैं हम ये साइट, इसका रीजन अभी समझ में आएगा. एंड दिस इज साइट नंबर 1, साइट नंबर 2. इस आयन चैनल का इट इज अ सोडियम पोटेशियम एटीपेज आयन चैनल. और इस आयन चैनल का फंक्शन क्या होता है? इस आयन चैनल का फंक्शन होता है ओनली टू रीस्टोर द एक्चुअल पोलैरिटी ऑफ द न्यूरॉन या टू रीस्टोर द रेस्टिंग कंडीशन. इट डजंट गेट बॉदर्ड अ कंडक्शन इज हैपनिंग और नॉट. It just see there are some difference, there is a disturbance in the normal polarity of ion channel. Maybe it is graded potential, maybe it is a conduction part. But if this ion channel sees any disturbance, it will start the correcting polarity. How it will correct the polarity? इस आयन चैनल के पास में दो तरह की साइट्स होती हैं. द येलो वन इज सोडियम बाइंडिंग साइट एंड द पर्पल वन इज द पोटेशियम बाइंडिंग साइट. अब ये जो सोडियम बाइंडिंग साइट है, ये क्या करता है, इस पे एट अ टाइम 3 सोडियम आयंस को अपने साथ बाइंड कर देता है. ठीक है. एंड दिस आयन चैनल ओपन्स आउटसाइड. नाउ दिस आयन चैनल एक्ट लाइक इट. आफ्टर बाइंडिंग सोडियम, दिस आयन चैनल will become like this. This is sodium, this is sodium, this is sodium, this is a cell membrane. This is how this ion channel, this push sodium outside of the cell. जब इससे सोडियम फ्री हो जाएगा, तब ये क्या करेगा, ये नए पोटेशियम को जो कि ECF में चला गया था, जो सेल के बाहर चला गया था, वहां से ये पोटेशियम को लाएगा और अपनी इस साइड पे लाके बाइंड कर लेगा. नाउ द स्टेप नंबर 3 will be, अगेन दिस इज योर सेल मेम्ब्रेन. ये आयन चैनल जो है आपका अब इस तरीके से फ्लिप हो जाएगा एंड ये जो पोटेशियम इससे बाइंडेड थे, इनको ये सेल के अंदर रिलीज कर देगा. नाउ व्हाट इज द रिजल्टेंट ऑफ दिस? द रिजल्टेंट इज 3 sodium goes outside, like 3 sodium efflux and 2 potassium influx. What is the resultant of it? Net plus 1 ion goes out. Now come to this again. Net sodium ion came inside, one charge came inside. With the help of this sodium potassium ATPase pump, again the one net charge goes out. This is how after consistent working, after consistent opening and transporting the ion, this sodium potassium pump will maintain the actual resting condition. And why ATPase? If you have ever seen the A's word here, this category denotes an enzyme which is a lysing enzyme. So this ion channel also act as an enzyme. Yeah, this we can say this ion channel is not just a channel, it is a kind of an enzyme which is made up of some proteins, and these proteins are facilitating the ion to move across, and these proteins act as an enzyme and which can break down the ATP. And with the ATP, they do their function to opening and closing, yeah, to flipping these sodium ATPase pump, yeah, sodium potassium ATPase pump. They need some energy, so they break down the ATP here. They extract some inorganic phosphate from the ATP. By the binding of inorganic phosphate, this channel open and close, and this is how they transport the sodium outside, 3 sodium efflux and the 2 potassium influx. Again, wash out your all wrong concept you have heard before, या you have seen the books before. सोडियम पोटेशियम एटीपेज पंप का नर्वस कंडक्शन से कोई लेना देना नहीं है. आपके रेस्टिंग मेम्ब्रेन पोटेंशियल में जब भी डिस्टर्बेंस आएगा तो फाइनली इफ यू वांट टू रीस्टोर इट, एवरी सेल वांट टू रीस्टोर देयर रेस्टिंग कंडीशन, ये आयन चैनल रीस्टोरेशन का काम करेंगे. 3 सोडियम को ये बाहर भेजेंगे, 1 पोटेशियम को ये 2 पोटेशियम को ये एट अ टाइम अंदर भेजेंगे, सो दैट द नेट +1 का ये ई फ्लक्स कर देंगे. दिस इज हाउ दे मेंटेन द एक्चुअल रेस्टिंग कंडीशन ऑफ द सेल मेम्ब्रेन. सो नाउ this was the graded potential. What is graded potential here? Any potential. One is higher than RMP or less negative than RMP, generated due to ion influx, and most important one, not able to initiate conduction. And why it is incapable to initiate conduction? Because it is not of enough strength, that is of threshold value. So ion channel will not be opened on this graded potential.